What's up guys, welcome along today and thanks very much for joining us. Today we're back in a workshop, quick little job. We're doing a bit of suspension servicing over there on the bench. Now one of my more popular videos is actually rebuilding a set of these forks exactly the same, but I didn't really go into detail of the top cap setting for the rebound adjustment on it. So whilst we've got these apart, we'll quickly run through that, go through some details. So let's get to it. Here we are then, we've got one of the forks disassembled, and here we've got the other complete top cap from the other fork, and here we've got the disassembled top cap components of this fork. So we're going to talk through how this works and how to make sure we set it properly. These forks actually did have the wrong setting on them and they only had 6 clicks of adjustment, and we'll explain why that was later on. We've got the spring and bits over here, the damper rod and the damper cartridge itself. So for those of you not aware how this works, this is the damper rod that passes up and down, and inside there is this tube. And what happens is as the damper rod goes up and down, it's forcing oil through holes, which is what and the flow of oil through the holes is what controls the damping effect. Now when you adjust your rebound, this is normally attached on there in the top of the fork. When you adjust your rebound on the top here, on this adjustment there, what that actually does is it pushes this rod further in or out to allow more or less rebound damping. So that's the principle behind how it works. So how does that work and how do we actually set that incorrectly? Well, here we've got the disassembled cap, which is just the complete cap that's empty. Here we have the preload adjuster. Now the preload adjuster screws into that top cap like so. And to stop it going all the way in, it's got, obviously runs out of thread. You've got the ends of the threads here, and to stop it coming all the way out once it's in is this little retaining circlip. So once it's screwed in, that circlip goes on and that acts as a mechanical stop, so you can't just wind it out as you're removing preload. So that guy goes in there. Inside that we've got your rebound adjuster, which goes in from the inside with this little O-ring on there, and it goes in with the O-ring like so, and then the circlip goes on there to stop it falling out. That's then screwed into your cap, and this little guy here actually locates in the other end of there. You can see there's a flat on there, like a flat-headed screwdriver, and a groove cut out of that. And when this is all assembled, that actually slots in there like so. So as you turn your adjuster at the top, it's locked to this other side and it turns the entire mechanism together like so. On the end of that there is also a couple of threads, and that threads into that side of the cap like so. There we have it. Now on this particular fork cap we've got a clicker mechanism, so you can hear as you're turning the adjuster. Some of them don't click. The reason that's clicking is inside this assembly here there's a little hole with that tiny little detent spring and ball, which as this rotates clicks in and out of these detent locators, which is what gives you your clicking as it spins around. Some caps will just continuously spin with no clicks where you count the turns. This one's a clicking type. So when it's all together like this, if you actually wind that all the way out, you will reach a mechanical stop that will not turn any further out. Once it's turned all the way out, there we can see. If we wind it in, you'll hear it goes through all the clicks, and then it actually winds off the end of that component there, and it actually turns that out of the fork cap. So if we wind it too far in, it will actually unwind that off the end of the cap. So the only real datum point we've got is with it fully wound out, because that is the mechanical stop there. So when we set these caps, we must always wind the rebound adjuster fully out and use the height of the lock nut to set the correct amount of range. So I'll give you a quick example here. On this cap here, we're fully out at the minute, and we'll count the clicks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whoop. 13, 14, 15, 16, 17, and then it stops clicking. So we've got 17 clicks of adjustment range. That doesn't necessarily mean the manufacturer is going to use that full range. They may well keep it a little bit further back from fully extended to stop this unwinding out of the thread inside there. You can see, hopefully, here as I'm turning that adjuster, how it turns that in the end of there. So what we'll do, we'll wind it all the way out. This is now in the correct position to set our adjustment. We've got our damping rod in there. Obviously this is normally fitted in the fork, it's just removed for display purposes. Now I know on this fork the setting of the lock nut is 11 millimeters from the top to the face of the nut. So if we actually set this shorter than that, which is, let's just grab this rule, hopefully you can see that is more like, do it in mil, that's more like 5 millimeters from the top. If we now wind our top cap on, imagine we've locked it off in the fork. When we go to change our rebound damping, remember we were previously wound all the way out. That's our 17 clicks, and then it continues to wind around, and what that's doing is actually unwinding this out of the top cap. So that is incorrect because obviously it's carrying on trying to push it out. Likewise, it can be the opposite way too. So the original problem we had with this fork was the lock nut was too low. So if we wind it down too low, this is again wound all the way off against its mechanical stop, and we wind it in down to the lock nut like so. And then on the rebound adjuster, 1, 2, 3, 4, 5, and that's it. We've now only got 5 clicks because it's actually forced that rod all the way down to its stop in there. Right, so now we've seen the components and the theory behind it. Let's put this together as if it was in the actual fork. Don't forget to put your rebound rod in before you put this together. So we know to set it, we have to back the rebound adjuster all the way out to our mechanical stop, which it is, and we need to set the lock nut height on the actual fork cap, which I know on this fork is 11 mil. So there we have 11 mil. We'll screw it together. Like I say, obviously this would normally all be within the fork, and you would nip that up. Now let's check how much adjustment we got. We know we've got 17 clicks at the full extent from one end to the other. Like we said, it may not necessarily use that full range though. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 clicks. So luckily I can still count. So you can see there they've actually manufactured it so that it stops 1 click before it reaches its total end of adjustment. Hopefully that has explained that in some random detail to you guys. There we go then, only a short video for you today. Hopefully it's been of use to some people. Main takeaways from that is make sure you always back your rebound adjuster all the way out against its mechanical stop and set your fork cap height with the lock nut as specified by the manufacturer. That way you should always have your full rebound adjustment range, and obviously if they're fork legs that share rebound and compression in both legs, they should be the same each side. So hopefully that's been useful to somebody, or I've just rambled on and confused people even more. Anyway, I hope it's been entertaining. We'll see you soon. Ta-ta!